All right, we're going to be dealing with some more inverses, and these inverses are going to be done just a little bit different. The fact is, these inverses don't just have variables, those variables have meaning. So our goal is to be to model with the inverse of a linear function. Please highlight what I highlight. All right. And learning target K, I can model the inverse of a linear function. We're going to go through hopefully A and B on here and then leave you C, and that should leave us a really short video after this to finish up the weekend's notes. In a model for a real-world situation, the variables have specific real-world meaning. For instance, here we go. If I'm dealing with this guy, d equals 60t can be used to represent distance in miles traveled and time in hours at a constant rate of 60 miles an hour. When written in function notation, this would be the d function when t is my input of 60t, distance with a relation of time. All right. To find its inverse, we solve for t to obtain the function. So I'm going to do that down here. In this situation, we're going to set this up, all right? And we don't switch like we did with the x and I, because switching would turn distance into time and time into distance, and we're not really doing that. We're just setting up a function. And so to solve for t, all we're going to do is divide by 60. Divide by 60. And if I bring that over here now, time is going to be equal to distance divided by 60. Alright. Or maybe the t function, when I plug in d, is related to d over 60. So, those are inverses. And this would be, you know what? Time is my output and distance is my input. And this distance is my output and time is my input. Alright. This represents time as a function of distance, time as a function of distance, because the meaning of variables cannot be switched. Alright? We do not interchange them. No amount of switching is going to turn time into distance. Alright? We often do this when we're solving unspecific functions, such like we did on the last page with x and y. In fact, we may even need to restrict the domain and range of the inverse so it makes sense with the situation. And let's go ahead and do that. All right. We're going to come down to example 2. Example 2. For the given function, state the domain. So let's underline state the domain of the inverse using set notation. Set notation. Find an equation for the inverse of the function and graph it. And interpret the meaning of the inverse of the function. So let's interpret the meaning of the inverse of the function. All right. So here we go. The equation C equals 3.5G given the cost in dollars as a function of the number of gallons of gasoline G when the price is $3.50 per gallon. All right. So this is cost in relation to gallons. So let's think about it. Let's just make a reasonable function here. The maximum I've ever seen in a gas tank is, you get those big trucks might hold 20 gallons. But most of these cars, most of these cars probably only hold 9, 10 gallons. And if this over here, this chart, is any indication, we're going to cut it off at, I don't know, let's say the domain, we'll call this a small car, is going to be from 0 to 10. Generally, you don't go in the car as empty, but my small car holds about 12 gallons. We're going to say this one holds a little less, about 10. 12 would be a reasonable domain. I guess because of that, I guess 15 would be a reasonable domain, but this time I'm going to choose 10. Alright, it's kind of easy. My range would be my output, and my range, since my output is cost, well, if everything's $3.50, would be from 0 to 3.5 times 10, $35. Alright, you know what? I should be using a different type of notation. So we're going to use interval notation in this situation. I know it said set notation, but I'm doing a video here, so let's keep going with it. All right. So we're going to find the inverse of the equation. So I come down here. C equals 3.5 per gallon. We're going to divide by 3.5. We're going to divide by 3.5. And I get gallons are equal to the cost divided by 3.5. All right. Let's go ahead and write that as a function notation. Gallon and cost is my input, so the g function for cost is equal to c divided by 3.5. All right. So let's go ahead and find the domain and range of the input. Well, domain and range. All right. Well, in this situation, we'll write this in set notation. I should have done this before. So my domain in this situation, if you think about it, is now my cost because we've done an inverse function. So my domain is just going to be the switch of it. So here we go. We're going to say brace. We'll do C bar, right? Because our domain has to do with C. C bar. And we're going to say C is less than or equal to 0. We could spend that. And or greater than or equal to 0, and less than or equal to, you know, somewhere around a maximum of $35 if we fill this small car up. And now my range is going to be the opposite. So my range, all right, so my range has to do with the gallons. So we're going to say G bar, right? 0 is less than or equal to gallons, which is less than or equal to 10. All right? And there we go. Let's do one more together, and I'm going to leave you the back one. So this says a gas tank holds 14 gallons of gas, so we know what it holds, and it already has 4 gallons. All right, so our start, if we're filling this up, we've already got 4 gallons. When the driver stops at a gas station to fill up the tank, the gas pump dispenses gas at a rate of 5 gallons per minute. All right, so the equation, gas is equal to 5 times t, which is going to be minutes, right? Time in minutes, plus 4. So the gas, we've got 4 gallons in there, and we've got 5 more gallons every minute. Because the number of gallons, G in the tank, is a function of time in minutes. All right. So we're going to do everything they said up front. Let's find a reasonable domain of the original function. So let's do domain. And we'll do range. All right. So time. Well, we will. Let's do set notation this time, since they asked us to do set notation. I'm gonna adjust this paper so you can see what's up right on there. All right. So my domain has to do with t. So let's talk about the amount of time we could spend here. And it looks like if we've got 14 gallons up here, and we already have 4, we can only put 10 more in. So my time is kind of small here. It looks like at 5 gallons per minute, it would take me 2 minutes to put the other 10 gallons in. So I'll say t, all right, could be less than, greater than or equal to 0 and less than or equal to 2, because by then my gas tank is filled up. All right, let's do the range. All right, our range is, we're talking about gallons now, right? So I've only got 10 gallons to go if I've got a 14-gallon tank, and I've already got 4 in there. So we'll say gallons is less than or equal to 0 and greater than or equal to, I'm sorry, greater than or equal to 0 and less than or equal to, in this case, 10. And we'll end it up right here. All right. So we are going to come down here and find an inverse function. G equals 5t plus 4. Solve for t. We're not going to switch the g and the t. G minus 4 equals 5t. Divide by 5. Here we go. And I'm going to switch the sides. I'm going to say my time is equal to 1/5 per gallon minus 4/5. All right. Now, Domain and range of this is really just going to be a switch. If this was our limit up here, it's also going to be a limit down here, but our domain has changed. Alright, our domain used to be about time. Alright, now our domain is my new input. It's in gallons. So I'm going to say set notation. We're talking about gallons, so G bar. And again, we can put a total of 10 gallons in this car. Alright, and our range, if we pump the entire time, alright, the most it'll take us is going to be 2 minutes. Alright, just because we should. Let's see, I'm checking the time to make sure I'm not running out of time. It's getting close, so I'm going to try to graph these functions real quick. So I'm going to graph the original function, which I'm going to kind of put a box around right now, right there. And that is 4. Let's put our y-intercept on, and this can be really hard to see because it's a slope of 5. Slope of 5 is really tough to do. I'm going to say something like, we'll go over 1/5 because it looks like it goes up 5 every time it goes over. So I'm going to make a line like that. All right, and let's go ahead and check the next one. That starts at -5/4, and if that's a scale that goes by halves, we'll start right here. There's 1. -4/5 would be like that. And wow, the scale on here. Let's see if I can do it. It goes up 1, so we'll go up a whole 1 to here, and we gotta make sure we're incorporating the scale over 5, and over 5 would be about here, and I'm gonna get something that looks like this. Alright, it's kind of interesting to, if I keep going with this, we can see that those two will eventually cross, and I'm a little off on that, and I want to point out that if I drew, again, let's see if I can do this. If I drew y equals, well, this scale is making it tough to see, so we'll just do our graphs. Anyway, that is how you find an inverse function, and that's how you switch the domain, and just the process of thinking through it. I'm going to end this video. I would like you, do not wait till class. I'm going to highlight this. Please highlight the same thing I'm highlighting, and this will be your discussion tomorrow in class. And I'm going to talk about this in one more video very soon.